Hi, good afternoon. Today we will be talking about defensive architecture in the context of cybersecurity. So let's move forward. The very first thing that we want to actually inform about the way that we approach the cybersecurity in our organization or in our university is that we actually try to bridge both the theory and the practice in technical education. So, having said that, we want to actually apply the use of the gamified capture the flag games in which we give you a practical lab in which there is a vulnerability hidden and there is a treasure hidden, virtual treasure is hidden. You have to go and try to find out the solution to the given hacking problem and try to solve the problem and to try to get the capture the flag. We also provide cyber ranges in which there are misconfigured systems, there are systems which needs to be hardened, and there are systems which are used for threat management and things like that. We also have cloud sandboxes available for both Azure from Microsoft, GCP from Google, and AWS from Amazon. Moving forward, let's concentrate on the today's topic of the defensive architecture. Let's look at two images. One of the images is of a corporate building, and another of the image is basically of the castle which is located in a countryside. So we want to hide our treasure, or we want to hide our important data inside these two buildings. We want to hide, let's say we want to hide gold inside these two buildings. Which building you will prefer? Of course, if we talk to majority of the student, if we want to hide a large sum of gold in this in one of these buildings, we will be trying to save the gold in the castle. Why? Because castle has multiple layers of defense. Castle has a perimeter boundary, have the gates, have the guards available on it, and then there is internal gates, and there is restricted access to particular section where we can go and safely store our so-called our gold. So now let's try to map this concept the uh, into the practical world where we want to secure an organizational database. So not only we will be actually applying the security from the outside internet, but we will be also providing security from the internal applications as well. So not only we will put a firewall to filter the traffic which is coming from the internet to our web server, we will also be actually uh, performing filtering at the web server and filtering the traffic which is passing from web server to the internal database where our actual data is inside. So if you see, this is also following the same principle which Castle is following. We are performing defense in depth. We are actually putting restriction at different levels. We are putting the security gates at a different levels to pass data from one layer of the organization to another layer. So the core thing is our data, which is the internal database. So we have hidden that internal database beyond many security gates. Okay, so we have a firewall, then we may have a DMZ, demilitarized zone, and then we have a web server, and then we have another firewall, and then we filter and run the intrusion detection, intrusion prevention system, and then we only can go to the internal database. Okay, so what we want to do is we want to see that when we are designing a defensive architecture, we do not rely on one particular layer. We try to develop multiple different means, mechanisms, and controls to access the backend database or to access the actual treasure. So if we want to wait for our kinesthetic learners now, we want to actually give a poll to actually question and to let them think about this thing. That, for example, if an insider want to steal valid employee credentials, which defensive layer is most critical? So I give you few minutes. You can log into, you can take the QR code and go to the Mentimeter and actually can submit your answer. Very well. I seen that most of them actually have answered the least privilege access control and multi-factor authentication. This is exactly on the point. This is correct that when we want to actually safeguard our organization from the insider threat, we actually want to use the principle of least privilege as well as the multi-factor authentication. Okay, so now we want to move ourselves and to see the importance of defensive architecture. We want to move ourselves towards the towards a real world example that how a mistake in implementing defensive architecture can lead to a data breach. We study the actual happening in 2013 about the Target breach, in which their main systems were properly secured, but their HVAC or their heating and the cooling systems and their that network was not properly secured. So the hackers get a chance to enter the that particular system of the target branch, and then they do a lateral movement where they actually escalate the privileges into another network, and they try to actually steal the 23 million credit card data. This is the typical study which we study in the case of the defensive architecture. So the mistake which has been done by Target is that they secure their main systems, they secure their main POS terminals, but they forget to secure their secondary system, which is supporting their aircon maintenance and all that, and which is still connected to their network. So what the hacker has done, he has find a opportunity in which he comes to that backend systems which are apparently connected to aircon systems and just part of the network, and he move his credentials and he move his role from that network into the main network and steal 23 million database passwords. Okay, so what we want to one more time highlight here is that what is the method of defense in depth analogy. So let's say if you still are confused and you still haven't got to the idea of what is defense in depth, let's we say that how you go and catch a flight. So at the airport security, you first show your ticket at the entrance. This is the concept of the perimeter security. So at the time of the entry to the airport, you are being passed at who you are, whether or not you are allowed to the gate. Okay, then you pass your bags through X-ray scanner. This is the concept of deep packet inspection. Just now we are saying that we are putting a firewall, and that firewall is performing deep packet inspection and actually passing the data after doing thorough inspection of the packets that are coming from outside world to inside world. And then you present your passport at the boarding gate, maybe your identity authentication. If your authentication and authorization to a particular resource is not known, then you will not be allowed to access that particular network. And even inside the plane, the cockpit door is locked, so that is the host level hardening. So even though that we have performed defense in depth, we have put firewalls, we have put defense DMZs, we have put intrusion prevention system and intrusion detection systems, we will still perform hardening of the database system itself, database application, as well as the database operating system as well. So that even in case somehow that a hacker can pass through a particular particular security gate, he will still be kept out of the main main important credential data. Okay, so now we will switch the topic a bit. We will ask you to do a 10 minutes think, pair, and share for securing a medical server. So you actually spend 30 seconds to 1 minute writing down your three choices. For example, whether you want to put backup system, firewall, encryption, or whatsoever. And then you pair, you spend 2 to 3 minutes to debate with your partner to agree on a unified list of three. And then after that, you can share with all of the class. So we will spend 5 to 10 minutes to do this particular exercise. And then after that, we will be actually moving to the assessment of the lecture. So we will have formative assessment, interactive polls, as well as Kahoot games, depending upon organization to organization policy. And then we have think, pair, share, peer reviews as well. So what we do is we try to do formative assessment where we see that students are picking up the idea and they are trying to understand the idea. After that, we will do the summative assessment in which we will be performing a hands-on laboratory practicals where students will be given intentionally misconfigured virtual network and they must successfully harden it using an automated attack script. Okay. and then we will pass the rubrics that how this particular practical will be actually marked and checked, and how the marks will be assigned to the students. And the continuous is we also actually ask the students to give feedback at the end of the lecture, that whether what are the most confusing concepts and are the most important point that they have learned today. Since we know that cybersecurity is a very demanding and challenging field, and it changes at a very rapid pace, we have two major pillars. We have pedagogical evolution, where we conduct workshops, seminars, and student interactions to learn about what are the current needs of the cybersecurity in the education. And at the same time, we follow the technical currency in the sense of doing latest cybersecurity certifications, studying latest defensive frameworks, latest threat research, and latest threat hunting exercises and hackathons. Okay, so we in our organization we join together both of these two pillars. We look at the technical currency, where we actually perform all these updates into our cybersecurity knowledge by certifications, frameworks, and hackathons. And then at the same time, we actually go and do conduct workshops with the industry people, with the students. We invite students to the workshops, and we discuss students with the lab sessions and the workshops to see what is the need of their cybersecurity information. In the conclusion, what we will say that in order to learn cybersecurity, especially the concept of defensive architecture, we will actually be linking the real world technical context with multimodal active learning strategies. We transform classroom from passive learning into cubicles of active critical problem solving. Thank you. If you have any questions, you can always reach to me at ahmedfarad@yahoo.com. Thank you for your attention. Thank you.